Good morning, Ankita.
Good morning, sir.
Good morning. वो प्रॉब्लम सॉल्व हुआ? वो स्पेलिंग मिस्टेक था। हाँ हाँ So today we'll start our last algorithm of supervised learning, which is SVM. SVM stands for support vector machines. So this is probably one of the most stable, powerful, I would say, algorithms, both used for both classification and regression, but mainly for classification purposes. And sometimes it is also referred to as an alternative logistic regression. Okay. Now, the biggest advantage of using an SVM is that it is used on nonlinear classes. Say non-linearly separable classes. Okay. Now, what is the meaning of this term non-linearly separable classes? So let us take one example. So in a logistic regression, let's say that let's say that we have a logistic regression. We 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 say So let's assume that there are two classes, positive class on the left-hand side and now let us assume that we have two classes. We have the positive class on one side and we have the negative class on the other side. So this is negative. Now, can I draw a line to separate the positive and negative? Yes, I can draw a line like this. I can draw a line like this. Okay, so all these are lines that separate out the positive and negative classes. This is known as linearly separable classes. That is, by drawing a line, I can separate out. Now, what if I have the class which is like this? So let's assume that these are my positive classes. So I'll mark them in green. These are the positive classes. And then these are the negative classes. Okay. Now I want to draw a line that separates positive and negative. Is it possible? If I draw a line like this, I'll have a 50-50. Okay, 50 correctly predicted, 50 incorrectly predicted. Okay, so you cannot draw a line. So how do you separate out these classes so that I get the negatives correctly here, the positives here, and I can draw line? Is this concept clear? Okay, so this is where support vector machines are used. Does this, it converts this 2D into a higher dimension. Okay, so 2D gets converted into a higher dimension. So maybe it gets converted into a 3D. Okay, so this conversion of 2D into 3D is done by something called as kernel. So kernels are basically maths functions. Okay, so they're mathematical functions that take the data as the input, changes its polynomial, maybe 2 level, 3 level, sorry, not level, 2 degree, the degree gets changed in such a way that the data which is non-linearly separable becomes linearly separate, increased.
Kernels are basically OS level changes, right?
OS level changes. It depends on the OS. It is dependent on the OS. Or I won't say OS, it is dependent on the machine. Because it is extremely machine sensitive.
Yeah, it's like difficult to define.
The processing is very, very, very intense. तो बहुत RAM लगता है इसके लिए. Okay, especially when you are processing millions of records and you're dealing with a 4 GB disk, it won't work. I mean, it will work. Your result will be there after a week because it is extremely resource oriented. Because kernels are mathematical functions. Okay, and it is a black box. You know what a black box is? Computer science, what is black box?
Most of your machine algorithms of operating systems are stored
No, black box is a technique where you provide an input and you get an output.
Yeah.
Okay. How it happens, you do not know. It's not a box as such. Okay, it is a technical term. So when you won't find a box there, open the box, you'll find it. It is just a technical term that says, you give me the input, I'll give you the output. But how it is done, you have no idea. That is called black box. So similarly, SVM works is a black box algorithm. Okay, if I say I'm using a polynomial kernel. Okay, now what function is applied? You do not know. Okay, if I'm applying a radial basis kernel, there are 4 different types of kernels. Okay, radial basis kernel, polynomial, I'll explain all this. So when I apply that kernel, how it works, what degree it is taking, you have no idea. So everything is done internally so that you get the best accuracy or the best results. Okay, so that is why it is extremely resource oriented, machine dependent, and end of the day, you get a very good result. Okay. So that's the underlying thing about SVM, that it is used mainly when you have non-linearly separable classes. By using the kernels, it can be separable, and then you can do a classification. Now, what about multi-class? When you have a multi-class classification, how does it work? We have already discussed this technique. What is it called?
One hot encoding.
No, one hot encoding. When you want to perform a multi-class classification and you want to use logistic regression, for example. So how does it work? It uses the OVA technique. OVA क्या है? One versus all, or one versus rest. Okay, so what it means is, let's say that I have 3 classes A, B, and C. Okay, now support vector machines can work with only 2 classes at a time. Isn't it? We have seen this. So we have a positive class, we have a negative class. So how does multi-class work? So it will take 2 classes at a time. So A, B. So it will consider A as a positive class, B as a negative class, for example. So this will become one model. Then it will take A as one class, C as another class. This is model 2. Then it will take B as one class, C as another class. Let's say this is positive, this is negative, this is model 3. So in the first model, what is the probability of the classification, which has the highest probability? So take that. In the second model, which has the highest probability? Take that. The third one, which has the highest probability? Take that. Now combine everything and take which is the highest probability of each class. Okay, this technique is known as OVA method, one versus all. It is also known as OVR, one versus rest. So, okay. So internally, this is how the models get built.
So here we take the permutation combination, and after that, which is the maximum
probability,
we'll take that as a
so yeah, you get it automatically.
It is similar to this.
Decision tree does not use OVA method. Decision tree is voting method.
Voting. Yeah.
In decision tree, you get the voting. How many classes are there for this? Get the maximum count. Here it is probability. That's the difference. Clear? Online, Ankita, is this technique clear? The basics?
Yes, sir.
Okay. So what is the theory behind support vector machine is it draws something called as a hyperplane. So the goal of SVM is to maximize the separation of classes by drawing a hyperplane. Now, what is the meaning of a hyperplane? Now, suppose I have a point here, I have a point here. Now, I want to separate these two. What do? I draw a line. Okay. But when I have the same thing in a three-dimensional, let's say I have X, Y, and Z.
So what is that word called?
Hyperplane.
Hyperplane.
This is actually a word from vectors.
Yeah.
Maths mein pada hoga vector 12th mein. So it is from that. I mean, I won't get into vectors, mathematics and all. Okay? Just some very basic stuff. Now, when I'm converting the 2D into a 3D, now I want to separate a 3D. Let's say that I have a positive point here and a negative point here. So how do I draw a line in a 3D? You cannot draw a line. Okay, so you have to draw something called as a plane. So the plane will be something like this. Let's say. Okay, whatever separates the two classes or two objects, that is called as a hyperplane. A line is also a hyperplane, but in 2D we call it a line. But technically that is also a hyperplane. Okay. So support vector machines, because it converts it into a higher dimension, so it will draw a hyperplane so that the distance between the classes is maximized. Okay, I'll tell you with a diagram what is the meaning. So some other things related to SVM is, it is mainly used in classification. There are no assumptions with respect to the data.
Small question.
Follow.
Yeah, SVM is used basically for two classes, right?
Binary classification.
Binary classification.
Binary or multi-class.
But for multi-class, we are going to use that OVA, right? OVA.
No, it uses that technique internally. Even logistic regression, you can use multi-class. So depending upon how many classes you have, it is going to implement the OVA technique. So there are no assumptions with respect to the data. Whatever data you provide, it is going to work. Okay, just like the data in k-nearest neighbors. KNN, no assumptions. If you give me a data which has, let's say, age equals 122, it will take that value. Okay, but again, as a data analyst, you have to ensure that you don't have these extreme values. Okay. Now, this is also a kind of non-parametric. Okay, no formula is generated. Then
These two are the advantages, right?
which one?
No assumptions and no parameters.
Not advantages. These are the, you can say, characteristics of SVM. And the last one is, because it uses all these kernel functions where it is going to transform the data, it is always a good technique to transform the data. Just like what we did in K nearest neighbors. Because it uses the distance formula. So to speed up things, we always convert them into a standard scale or a min-max scale. We do the exact same thing in SVM also. So transform the data either using min-max or z-score. Okay, so these are some very basic things about support vector machines. Z-score. My handwriting is not very good, please bear. And complex algorithm computing resources high. So that is because of the kernels. So if you have a very slow system, you can feel when you're using certain kernels, it will just run forever. So this usually requires a very, very good system. Okay, so now let us look at a few things about the working principle. Okay, now let's look at this figure. So I just created a kind of small animation so that you can understand this. So here I have a binary class. So assume that red class is the negative class and green is the positive class. Okay. Now what happens in logistic regression? It will draw a line to separate these two classes. Okay, so this kind of a separation is called as hard margin classifier. Okay, anything which is on this side is one class, anything on that side is one class. Okay, hard margin classifier. Now, how is SVM different from this? Since both are considered to be, one is considered to be the alternate. Now, SVM is going to draw something called as a margin. Okay, now this is what a margin is. Now, let us understand the definition of this margin. What is wrong with this guy? So let's take a binary class. So we have the positive class on one side and negative class on one side. So this is the negative class, for example. These are the positive class. Okay, now this is the line of separation. Okay, this is hard margin. Now what SVM does, along with this line of separation, it is also going to draw two lines parallel to it. Okay. So it is going to draw two lines, which is going to be parallel to this line of separation. So one is this, and the other one is this. Is this clear? So the idea is to maximize the distance. So here the distance is the distance between the two nearest points of the two classes. So here, let's say that I have a class which is this one, and here I have a class which is the green one. Okay. So I need to maximize the distance. So what is the distance? It is calculated as the distance of red, that is the point with the line of separation. So this is D1. And then the distance of the green point with the center line. So this is D2. Right? So we have to maximize D. That means D is the total distance. Okay. So this is the hyperplane. So hyperplane separates the two classes in such a way that the distance between the two nearest classes has the largest margin. Samajh mein aa raha hai? Now, what are the other conditions? The distance between D1 and the center point, that is this point and this point, and this point and the center one are equidistant. So D1 and D2 are equidistant. That means the length of D1, that is the point of the red with the center line, whatever may be the distance, and the distance of a green class with the center line, that the distances are same. So D1 equals D2. And this entire distance is the margin.
D1 plus D2 is the margin. Right?
This entire thing is the margin. D1 and D2. D1 plus D2.
So the hyperplane which we are drawing, it is going to be an imaginary line, right?
It is an imaginary line.
Basically, we are just bifurcating between two classes, and the hyperplane is keeping that an imaginary
classes separate.
Classes separate.
This is not a hyperplane. This is a line, because this is 2D. So if you imagine this in 3D, where I am converting my, let's say the value is 2x. So 2x is a 2D object or 2D value. Now, if I convert this into 2x into x plus 5. Okay, so I'm increasing the dimension. Is this clear? Okay. So we have to maximize the margin. What are the other conditions? The distances from the central line are equidistant. So that means D1 and D2 are same. Now, the other things that we have to remember is when we are drawing these lines, these parallel lines, let me just erase so that you. Okay, so these dotted lines, so these are the two parallel lines. So any data or any class which is lying exactly on those lines. For example, here I have the red point, which is lying exactly on this line. And here I have this green point, which is lying exactly on the dotted line. So whenever I have these classes that lie on the dotted lines, those classes are known as support vector machines. Okay, so imagine that there is a, someone is holding those planes. So what are those points? Those points are known as the support vector machines. So those are the records which satisfy this condition of maximizing the margin of the two nearest opposite classes. Clear? So this distance that you see here, so I can have the classifications. Whenever I have a red point here, it means correctly classified. If I have a green point here, that means correctly classified. So that means I'm giving enough margin so that there are no errors. So what I mean is, if I have a classification which is lying here, that is in that cushion, that is misclassification. That is wrong. Okay, that is why I'm leaving enough space so that you are correctly classified. Anything which is lying in this region, that is misclassification. Anything that lies on the other side, for example, if I have a negative point here, it means misclassification because it is lying on the positive side. Similarly, if I have anything which is lying here for the positive class, that means it is a misclassification.
So the bifurcation is not going to signify the positive or the negative. It's just going to bifurcate the class.
You are actually defining something called as a boundary. Okay, so you cannot build a I would say, an error-free boundary line. You are building a boundary that is going to generalize the classification. So that generalization will depend on how narrow or how wide the boundary line is, which is the margin basically. So we want to minimize the number of classes that appear inside the boundary. Okay. Now, is that possible to build a class like that, a model like that?
Yes.
Suppose I say that everything should fit here, everything should fit here. I can build it, no issues. Okay. I can train the model in such a way that everything fits here for the positive class, everything fits here, sorry, negative class and positive class. But when I test the model, will it behave the same way? No, that is when it will fail. So I need some provision so that the testing model should not fail. So I want to generalize it in such a way that in the training itself, let it fail, but at least in the testing, it should not happen. So that is determined by the width of the margin. So how do you want the margin? Do I want a margin like this? Do I want a margin like this, or a very narrow margin, or a wide margin? Okay, this is just like we do in other algorithms also. How much depth we want for a tree. So this is some kind of a hyperparameter. So that margin is determined by two variables. One is called classification, cost of classification, which is a C parameter, and the other one is called as the gamma parameter. Okay, we'll see that example now. What is the influence of this? But is this clear? Right. So here it says, the hyperplane leaves the widest possible cushion. The cushion is the distance. This is the cushion. So do you want to leave very little space so that errors are minimized? Or do you want to leave a wider space so that there are errors, but the model is more generalized? Yeah, larger space means more errors, but more generalized. Smaller margin, very strict model, no errors, but it is prone to overfitting. You have to be very sure that your testing and training data will be so similar, or the future data, so that there is no chance for any errors. Then you can fit a model like this. So we will generally go for a model which is okay with training errors, so that my testing does not hamper. Okay, so that is done by two parameters, C and gamma. And the choice of this is given by cross validation. Cross validation is a technique to select optimum C and gamma values to build a generalized model, generalized SVM model. So just look at some basic maths. So here it uses the formula y. Y is the class that we want to predict. W transpose X plus B. This is exactly the same formula that we had, mx plus c, or y equals a plus bx. Notation यहाँ पे थोड़ा different है because it is vectors. Now w equals y equals w transpose x plus b. So where y can be greater than 1 or equals to 1 for positive classes. And y less than or equals less than y is less than 1 for negative classes. Okay, now what is the formula for those lines? So here I have, let's say this is a line of separation. So this is going to be W transpose X plus B. So here Y is going to be 0.
It's always going to be 0.
Always going to be 0.
Center line is going to be 0. Margin line is going to be 0. Margin line is going to be 0.
Yes. Not marginal line, line of separation. The one, okay, let me put green color. Can you tell me what will be the equation of the red line? Same thing. Y equals W transpose X plus B, but Y is less than 1. Okay, or you can say less than 0. Because it is on the left-hand side of this. All negative classes. And for the positive classes, Y equals W transpose X plus B, where Y is greater than equals 1. Okay. We'll just take one example to understand a little bit of the maths part, not really required, but good to know. So let's take this example. So 2x plus 3y minus 6 equals 0. Let us say this is my point. Now, how do you plot this point, this line? So this is in the general equation of a line. Ax plus by plus c equals 0. Remember this equation in school? Lines pe We won't get into much, just basic understanding. Now, suppose this is my data. Now, how do you plot this point? So I want to find what is X and Y. Okay. So what is the value of X here? 2. Isn't it? 2 or 3? Value of X. So how do you get the value for X? You put Y equals 0. So you get 2X equals 6. So X equals 3. How do you get the value for Y? Put X equals 0. So put X equals 0. So you get Y equals 2. So the points are 3, 2. So now plot 3, 2. This is 0, 1, 2, 3, 4, 1. So which is 3, 2. 3, this point, right? So now let's draw one line here. So approximately this is the line. Now, how do you draw the line which is to the left of this and right of this? So that will determine what is the margin. Right? Now, what will happen if I... Okay, so how do you draw this line? This line and this line. How do you draw? Let's assume this is negative class and this is positive class. Can you tell me? The equation will be 2x plus 3y minus 6 equals -1 for the negative class. And for the positive class, 2x plus 3y minus 6 equals 1. That is a general form of the equation, isn't it? And use the same technique. So what will happen if I put 2x plus 3y minus 6 equals 1 and -1? So this is for the positive class. This is for the negative class. And when I use the same technique of finding the X and Y, I will find that the margins will be something like this, very close to each other. Okay, so let's put this guy here. This is the positive class. And let me take this guy. It will be something like this. Okay. Understood? Basics of the line. Equation of the line क्या है? Negative and positive का. Ax plus by plus c equals -1 for the negative class. Ax plus by plus c equals 1 for the positive class. और लाइन ऑफ सेपरेशन का ax plus by plus c इक्वल 0. तो सेंटर लाइन मैंने रेड लाइन ड्रॉ किया है यूजिंग दिस इक्वेशन. ओके. मार्जिन का लाइंस ऑन व्हाट बेसिस? यूजिंग द +1 and -1 as the value for y, because this is y equals ax plus b plus c. So when you substitute these values, you will get values for x and y. So for the positive class, you will have a line like this. For the negative class, we'll have a line like this. Just an illustration that how the hyperplane gets built. Now, can you tell me, is this a small margin or a large margin or a wide margin? Small margin. Okay. Is this model okay? Can we say this is a generalized model? Is this a generalized model or no? No. So how do we make this model generalized so that it doesn't overfit? What can we do so that my margins are wider? Can we change the value of x? X is my input data. Can we change the value for x? Input data को change कर सकते हैं. 10 के बदले I'll put 15. No. So I cannot change the data. So what is the next option that I have? How can I change the output? How can I convert a negative class to a positive class?
Quantity of the data.
Look at the equation and tell me. What is the equation? Y transport. Let us say the data is in some form. ठीक है, तो data तो वही है. Whether you transform it in whatever way, your input is the same, which cannot be changed. So what can be changed? This is x, W transport x plus B. So you have only two things to change, the weight and the bias. Isn't it? Linear regression, same thing.
B is going to be our constant.
B is the constant term here. It is not a constant value.
It's going to be something specific. Suppose, for example, in the normal equation, that y is equal to x plus c, c is a constant.
It is a constant term. It's not a constant value.
But we don't change that value.
Of course we do. मैं वही बोल रहा हूँ. You are confusing between constant value and constant term. Pi is a constant value. ये pi का technique नहीं है. That is universal constant.
No, but my point is that B value will be given by someone, right?
It has to be calculated.
It is going to be an input, like an input for a particular equation or. We cannot keep it same for everything, right?
It is not going to be same.
Yes.
So the value for W and B is going to be derived using using a technique called as gradient descent. ये नाम तो you must have heard this term. What is कहाँ पे था ये gradient descent? This is used in linear regression, logistic regression. Okay, how do you get the value for beta 1, beta 2, beta 3 in linear regression? Y equals A plus BX. A and B क्या है? Constant term and beta term. Okay, so A and B comes from where? Do you supply the value of A and B? No. So it will take a random value. I'm going to take A as some value, B as some value, because X is already there in my input. So using the random value, I'm going to do the prediction.
Reduce the cost function. Reduce the cost function.
The cost function, yes. Abhi Y equals A plus BX. Okay, what is X? X is the input. Can you change the input value? No, input cannot be changed. So what should be the value for A and B such that this is Y hat, not Y, such that Y minus Y hat equals minimum error. Yeah, no objective. This is a cost function. So how do you get the value for optimum A and B? You don't supply till A take 20 and B take 30. It doesn't work that way. It has to be calculated. So कैसे होगा? First, I'm going to take a random value for A. I'm going to take a random value for B. Okay, so let's say the value is 1.113, 0.847. My X is already known. So now what is going to be my prediction? A plus BX, so 1.113 plus 0.847 multiplied by, let's say X value is 20. So this is my prediction. Okay, let's say this value is kitna? 20, let's say this is 23. Now, what is the actual value for this? You must be having that actual value somewhere stored. So let's say the actual value for Y is 29.8. So error kitna hai? Y minus Y hat. So let's say this is 6.7. Now, what is my objective? This error should be 0 or it should be minimum. So what do I change? Can I change X? 20, can it be changed? No. So I can change only W, I can change X. I can change, not W, A and B. So how do you change A and B? That is done using partial differentiation. Partial differentiation with respect to the error. Partial differentiation कैसे करते हैं? This sign. It is not D. Okay. So partial differentiation. So dA by dE and then dB by dE. So when you do the partial differentiation with respect of A with respect to error, B with respect to error, you get a number. And then you change that existing value of A as new value of A equals old value of A minus partial differentiation of A. Partial differentiation. Now, what will be the value of A? Now it is 1.113. Next iteration pe kya hoga? It will be less. Or it can be more depending upon the sign. What will be the new value for B? So new B equals old value of B minus partial differentiation with respect to B. And this will continue for, let's say, 2000, 3000, 10,000 iterations till you get the best value for A and B. This is gradient descent. Same thing is done in support vector machines also, where you want to optimize W and B so that you get the best classes. समझ में आ रहा? Okay, so coming back to this equation. Now tell me, how do I change the width of the line in this equation?
Yeah.
Same thing by changing the value for W and B. Okay, abhi 2x plus 3y minus 6. 2x plus 3y minus 6 equals 0. Now, if I multiply this value by 2, what will happen? What will happen to my central line? Sure? This is 1, this is 2, this is 3, this is 4. It will be the same, right? So that will still be 3, 2. Now tell me what will happen to the margin. Will it also be the same? Now margin will be different. So here I have taken the weight as 2. Now if I take the weight as 0.2, what will happen to the margin? That will be wider. So that means when the weights are increasing, margins are becoming smaller. When the when the weights are becoming smaller, margins become wider. You can do the calculation and find it. Simple calculation. So this is how you optimize what is going to be the distance. Okay, I won't get into too much of maths. Okay, just one more thing, one equation, and then I'll stop. Okay, this is just for your understanding that how it works. Ye clear hai? Online? Ankita, any questions? Okay. Okay, so this is how you find the distance. I'll just tell you the end formula. Pura chahiye, you want the full formula to be explained? Yeah, just I'll tell you the last part of it. It will take some time. Pura samjhane ke liye. Okay. No, implementation के लिए तो formula you don't really require it. Okay. Because I generally avoid this because a lot of people say, yeah, we don't remember all these maths concepts, so no point in. नहीं तो समझेंगे यार कहाँ आ गया मैं. No, this is not something. So I'll just tell you the main formula. Okay. So SVM is. So there are two kinds of formula. One is called as a hard margin classifier. So what is hard margin classifier? Where you draw the boundary line without any scope for errors. Okay. But support vector machine is not meant for a hard margin classifier. It is a soft margin classifier. So hard margin classifier, the formula is maximizing the distance 2 divided by the unit vector. Okay, so in vector maths, you have something called as a unit vector. So this is how you write the unit vector. Double line W, the vector name, and this. So this equation fulfills the basic definition of SVM, that is maximizing the margin. D is the margin or the distance. D for distance. Now, suppose I want to make my margin as a soft margin. Soft margin means more generalized, more scope for error in the training, such that testing data is reduced, errors are reduced. So in that case, I am going to slightly alter this formula and convert this into, so convert the hard margin equation, which is a maximum, so convert into minimum. So minimum money, I'm just going to swap or interchange numerator and denominator. So this is going to be minimum of W comma B. This is a soft margin classifier. Okay. Plus. So this is where I'll be introducing the two parameters that I told you, the C parameter and the gamma parameter. Okay. So here I have two parameters. One is called C. So C is called cost of misclassification. So what it means is, so here I have this line, and here I have the margin. Here I have the positive classes. Here I have the negative classes. So these are the correct ones. Okay, now what are the errors? The errors are positives appearing inside the margin, points appearing inside the margin, and then points appearing on the other side of the class. Okay. So the cost of classification is how many such points are there multiplied by the distance of each of those points from the center line. So that means I want to find out the summation of
Center line is like the main margin.
the line of separation. Okay. So this is a misclassification. What is the distance of this point from the center line? This is a misclassification. What is the distance of this from the center line? What is the distance of this misclassified with the center line? What is this from the center line? Then what are the other misclassified points? This one. What is the distance? This one. What is the distance? And then this one. What is the distance? And then this one. What is the distance? So summation of all these. Summation of distances of misclassified points. And this is known as eta. It is determined by a Greek character called eta. So summation of eta multiplied by the misclassification parameter called C. Okay. So if I have to complete this equation, so I have unit vector by 2 plus sigma of I equals 1 to n, that is how many points are misclassified, eta multiplied by C. So this is the equation for the soft margin classifier. Gamma will come. Gamma is not for all the kernels. It is only for selected kernels.
In this C value, we are going to figure it out with
C value, we are going to figure it out by using
gradient
cross validation. Okay, so this is the maths behind support vector machines. So here when I have a small value for C, it means large margin error. And when I have a large value for C, yes, not this one. And when I have a large value for C, it means that I have a small margin error. Okay, so here, which is the margin error in this equation? This is margin error, isn't it? So this is margin error, and this is misclassification error. So when I have a small value for C, the margin error becomes big. When I have a big value for C, the margin error is small. So how do you select the value for C? Whether I want a value as 1000 or whether I want a value for 5 as 10 or 0.1. That will be determined by the cross validation. समझ में आ रहा है?
Small, when see a small large small C large large C small.
So these are the different types of kernels. There are 4 main types of kernels: linear kernel, sigmoid kernel, polynomial kernel, and RBF or radial basis function kernel. So this RBF is supposed to be the generalized kernel. But again, you have to build a model and see whether it is actually giving you the best result or not. But over the, by experience, you can tell that generally RBF works very well. Now, when you are giving the value for C and gamma, for all these kernels, we have to give the value for C. That is cost of misclassification. Whereas for gamma, you have to give it only for, except for linear, all the others. So from polynomial, RBF and sigmoid, we have to specify what is the value of gamma. Now, what is the meaning of this gamma term? So it means that when you are drawing the line of separation in support vector machines, does the endpoint influence your decision? Okay, so when you plot the data, you have some points which is very near to the margin. There are some points which are far away from the margin. So does the point or do the points which are far away from the margins, do they have any significance in drawing the margin, yes or no? That is determined by the gamma parameter. So here, if you have some points And here I have some points. So the gamma parameter is going to determine what is the influence of this point in drawing the margin and the influence of the faraway point in drawing the margin. Okay, so gammas are very small numbers, very small values. So once again, based on the combination of C and gamma using cross validation, we will determine only for these three algorithms which combination of C and gamma gives you the best classification. Clear again? Okay, so here is just a small illustration that what gammas can do. So when you give a very high value for gamma, so decision depends on the closest points, which is near to the decision boundary. Whereas when you give a small value for gamma, it means that even faraway points can influence the decision boundary. So we generally give a list of values. जैसे हमने KNN में दिया था ना, for the value for K, 3, 4, 5, 6, 7, 8, 9, 10, 11. We gave a series of numbers. Something similar we give it for C and gamma here. एक list बनाएंगे. Then we give those values and then find out which combination works well for the given data and for the given kernel. Because kernel also we can select. Okay. So the list of hyperparameter tuning that can be done. So what are the list of hyperparameter tunings in SVM? Number one, the kernel choice. Number two, the value for C. Number three, the value for gamma. Okay, so here is an example of how to convert 2D into a 3D. I've taken a very simple example. So I have a data X. The value is 0, 1, 2, 3 and Y 3, 2, 1, 0. So the class of the first record is red. I can see here. Class for the second record is green. Class for the third record is red. Class for the fourth record is green. Okay. Now, when you plot these points, I get a linear line. Now, how do you convert this into? So, is this separable? You cannot separate this, isn't it? Even if you try to do it, you will get a 50% accuracy, which is wrong. So how can I convert this into a model where the classes can be linearly separated? So this is where we use the kernel function. That means convert this into a higher dimension. So what can be the higher dimension data? So if I transform this into the data like this. So X is there, Y is there. So I can do X plus Y. I can do X into Y. So I just given a couple of examples and X square. So when I do X plus Y, what is going to be the new data point? 0 plus 3, which is 3. X into Y, 0 multiplied by 3, which is 0. And X square is 0 square, which is 0. Okay, so my new data point is not X comma Y, but X comma Y comma X plus Y, X into Y, and X square. Now, out of these transformations, which transformation will give me the separation? Okay. Now, if I look at the data, X into Y is going to give me the transformation. Okay, so how X into Y? So now my data gets converted from 2D into a 3D, which is X, Y, and X into Y. So 0, 3, 0. If I plot it, I'll get the data something like this. If I plot the next point 1 to 2, it will be this. So I'm plotting 3 points: X-axis, Y-axis, and Z-axis. This is the third data, and this is the fourth data. Now, when I plot, when I draw the hyperplane here, I'm separating out the red classes and the green classes. Okay, so this is how 2D is transformed into 3D. So this is called kernel trick in support vectors.
Every time it will be X into Y.
Every time what?
It will be X into Y.
No, this is one example I gave. Now, what goes behind in the data, we do not know. You can create your own functions also, kernel functions. So that's SVM. So we'll take a break now, and after that we'll do the hands-on.
So the black box thing, the functions which are dividing that is basically done the black box.
No, that process is called black box. See, if you ask me, okay, can you tell me how to do this? So I'll say, okay, and this is the answer. Now, how did I approach the answer? I won't tell you. So your job ends when you ask me the question and tell you the answer. Okay, so this process of giving you the answer, that is called black box.
I was thinking that black box, we are going to just get a method. Like we have to call
it's a
function, and we are going to get, we pass the input and we are going to get the output.
That process is called black box.
No, my understanding was that function was is already inbuilt. We are not going to build that function.
No, we are not going to build it. It is inbuilt. That is what I'm saying. The process of getting the output without knowing how it has come, that is called a black box. So SVM is a black box. See, linear regression is not a black box. You know what is the output. You know what is the process. I can see the equation. So here there is nothing of that.
In decision tree also.
Decision tree also, you can see the tree. Random forest also, you can see the trees. Okay, so we'll take a 15-minute break. And आज वो नहीं आया, क्या नाम है इसका? Yash. I have given him the data set. Oh, अच्छा, good boy. So you download that data set, we'll do it today. Ankita will take a break. We'll meet by 11:15. And also download the data set for today's hands-on.
हाँ अभी तो फिलहाल तो फिक्स करना ही चाहिए।
अभी वही मार्केट की डाउन यूके यूएस थोड़ा स्टेबल नहीं हुआ, इंडिया का भी इम्पैक्ट 6 months अभी देखते हैं ये पॉलिसीज क्या चेंज होती है। 6 months हो गए, 6 months यहाँ पे 2-3 महीना मैं वो बोलिए को अब एक बार तो एक्सेंट करने के 25,000 लोग निकाल दिए हैं। या तो आज निकल जाओ, नहीं तो 7 months की पहले जाओ और आज निकल जाओ, नहीं तो 3 महीने नोटिस पीरियड सर्व करो। और अगर कोई केस में फर्स्ट निकले स्टार्टिंग 25 के तो निकाल रहा है उनको कुछ नो कंपनसेशन
क्या फ्रॉड
डॉक्यूमेंट्स मतलब सबने ऐसे इंस्टीट्यूट से एक्सपीरियंस सर्टिफिकेट्स बना के अप्लाई किया।
अच्छा एक्सपीरियंस सर्टिफिकेट
तो कंपनीज ऑन द स्पॉट वेरीफाई नहीं करती है ना कि आप वो तो टाइम को चेक करती है। तो सबने किया एक्सेंचर इन्फोसिस कंपनीज सब टीसीएस सबने किया। मतलब ये रीजन दे सकते हैं क्योंकि लोगों को निकालना था क्योंकि मार्केट बिगड़ा हुआ है, तो ये रीजन लेके अभी होने की हमको जब ऐसी नींद आती है ना तो हमारा नाम भी हमें चीज है। कंपनीज कभी ऑन द स्पॉट ज्वाइन ना एक्सपीरियंस करके नहीं चेक करती, कंपनी से मंगवा के रखेगी वो विद टाइम 1 साल 2 साल जब उनका वेरीफाइड उनको ऐसा करती है। ये भी मेरे को अभी पता चला, मैं भी पहले यही उसमें था कि मैंने दे दिया कंपनी वेरीफाइड लाइक 15-20 डेज में, बट नहीं टाइम बहुत कंपनी है उनको
ओके। डेटा से डाउनलोड हो गया। So we are going to start support vector machine classification. Okay, so this is the data set. So we have to predict whether a person is diabetic or not. I think I have shared this file also. Okay. So the Y variable is whether the person is diabetic or not, given the following features. So first feature is number of times pregnant. Then we have PG concentration, that is plasma glucose. Then dia-BP, which is diastolic blood pressure. Then tri-SF, which is triceps skin fold thickness. Then we have SER-INS, which is serum insulin. That's the next one. Then BMI. Then diabetes pedigree function. Then age. And then we have the Y variable. Now, what are the things that you will consider in this data set before proceeding with the model building? Any bad data here? So can BP be 0? BP 0 means, I don't know, dead person. So we probably and similarly try SFTH. क्या है try sulfur? क्या try triceps skin fold thickness. So that is also 0. And some research whether this particular feature can 0 or not. Okay, ठीक है. और क्या?
11, 12, 13, 14.
Correct. So those things are, you need to do the changes.
Next is class value. The positive determinant class for already 0 at 8. So when I'm considering strengths will consider those 3 days.
So we need to remove the Y variable called class. Okay, so that's the only change that we have to make. So remove class val, then do the EDA, then convert the data into, transform the data, okay, and then apply the kernels, cross validations, etc. Okay, so let's get started. Have you done grid search cross-validation method?
Grid search.
नाम सुना है grid search? What does it do?
Grid is basically a table, right?
Huh. So what grid search does is, instead of doing it manually, okay, you first configure the list of parameters that you want, the hyperparameters, and call this function called grid search. So that is going to run the for loop for you and give you the best parameters. That which combination of parameters will give you the highest result. That is called grid search. Okay, so here so in this example, we are going to use the grid search to do three things. Number one is define the kernel, define the value for C, and define the value for gamma. Okay, now what are the four kernels? Polynomial, linear, sigmoid, and RBF. Okay, radial basis function kernel. C values, I can take random values. So let's say that I take the value like this, 0.01, 0.1, 1, 10, and 100. Then gamma values, I'm taking some random values. Let's say 0.4, 0.5, 0.6, 0.7. 0 to 1, small values. So let's assume that ये तो fix है. Let's assume that these are my values for C and gamma. So how many models will be built?
Based on
Not 5. So when you are taking the linear model, linear में सिर्फ C है. For polynomial, linear, sigmoid, and RBF, we have C plus gamma. Okay. So how many models will be built? So यहाँ पे कितना models है? So this is 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 25 of this. C 0.01 versus all the gammas. C 0.1, all the gammas. So 5 into 5, cross product 25. Sorry. नहीं, यहाँ पे 5 आएगा. Sorry. Okay, this is 5. There is no gamma. Here it is going to be 75. 25 plus 25 plus 25. So total how many? 80 models. So out of these 80 models, which model gives you the highest accuracy? That is, which combination of kernel, C and gamma will give you the highest accuracy? That is what we have to use. उसको बोलते हैं grid search.
It will check the probability.
Accuracy, highest accuracy. Because that is the scoring mechanism for classification. Regression पे we have to use the MSE. ठीक है? Ankita, is this clear to you? Okay. So from model selection, we will include one more library called Grid Search CV. From sklearn import SPM. And pre-processing. Pre-processing will be used to transform data. So min-max and standard scaler. Then we will use metrics to import the classification report and accuracy score. Let's read the data. Diabetes equals. So here we can see that it has read the data, 10 columns. So we need to remove the variable called class val, since it is a duplication. So diab.drop columns equals. Okay, so now you can see the y variable is class. So is this a binary class or a multi-class? Multi-class है? Check किया? So check the class distribution. Now, can you tell me why I'm getting an error here?
Value
Class is already a predefined function.
Class is a predefined keyword in Python. Object-oriented programming mein, we use the term called class when you want to create an object. Okay, so when I'm using the class as a name of a column by using this method, it is giving an error. Okay, so sometimes we need to take that also into remember that when we are renaming columns. Okay, so instead of writing dot class, we can write square bracket and then give the name of the column like this. So now it will give the value properly. So number of zeros, that is negative class is 500 and positive class is 268. क्या तेजस इधर आ जाओ ना, इधर आ जाओ. Capital C small concentration. Do you generally type slow? Tejas? तुम रोज एक 10-15 मिनट ना focus on your typing. Try to increase that speed. It will really help. भले उसमें you get errors in the spellings, but at least वो get used to fast typing. और वो जो कवर है ना उसको हटा दो, एक दिन तो खराब होना ही है. And once you get that experience, you won't even need कौन सा लेटर कहाँ पे है, you know. मुझे बड़ा इरिटेटिंग लगता है वो कवर एट द टॉप. कुछ लोग तो एक एक्स्ट्रा प्रोटेक्शन भी देते हैं, वन मोर कवर ऑन द टॉप. आओ भरत. फोर मिकी माउस. So are we having a evenly distributed class or highly imbalanced class? What type of a distribution is this?
it is not even distributed. Like, it is half.
It is not even, it is not imbalanced also. Okay, there will be some imbalance and that is expected. So here I'm just going to include this line, perform EDA. That is checking for nulls, zeros, all those impute of data. Please do it here. Just check if you have any nulls or not. So there are no nulls in the data, which is good.
So if we have nulls, then we have to replace it with two.
Preferably don't drop it.
In this case now, so if we had nulls in this data, then what value would that replace?
See, right now there are 768 records. Okay, so assuming there were nulls. In let's say PG concentration or whatever column, okay. So even if there were 10 nulls and you remove those 10 nulls, so it will be 758 records. So that means you are reducing the record count. As it is come here, you're further reducing it. So that is not a good practice. There is 27,000 hota, for example. Then you remove 10, it doesn't make much difference. Okay. So nulls always have to be imputed. And use the best method, what you think is relevant. There is no right way, there is no standard way, there is no prescribed way, it is your way.
So let's say if we have nulls in each column, so I would prefer to replace it with the average age.
That's up to you. That is what I'm saying.
Because if we replace it with the maximum value or minimum value, then the model will be biased towards.
It could be. So
depending if that is an important parameter.
So the choice of imputing the null value is your choice. Because you do not know what is the actual data, you are only guessing. So it will have some impact on your prediction also. So let's say that there are 10 values which are nulls, okay, and you are taking an average. So average ka problem kya hai? All the 10 records will have the same value. Okay, so that is one problem. So is there a workaround? You can probably generate random values between the minimum and maximum of that particular column. That is one way. Or you can do filtering, selective filtering. For this combination of columns, what is the minimum maximum? And then for that combination, you generate random numbers. So there are n combinations. You select the best. For example, let's say number of pregnancy, the first column was null. Okay, now how will you impute it? So you can probably say, based on a combination of age, PG concentration, serum insulin and BMI. For this combination, what is that value? Okay, so something like this. So get creative. Okay, so that is up to you to figure it out. Zero ka same thing. First of all, you have to analyze whether zero is a valid value or not. Abhi, for example, number of pregnancies, can it take zero? Yes, it can. BMI, can it be zero? No. Then you need to fix BMI. और मेरे ख्याल से यहाँ पे there is a record. If you just do diab where diab dot BMI is less than equal 0. See, there are some 10 records where BMI is 0. So that means I have these bad records. और इसको कैसे fix करेंगे? What do you think would be the best method? One is random values between minimum and maximum. Z score से कैसे fix करोगे? Z score करने से बहुत कम हो जाएगा ना value. See, other option that you can use, look at these values. Look at for example, age. So based on the age, you can create bins. So between 20 and 30, what is the average value? Or what is the minimum maximum? And then for all those records, where for that age group, there is a BMI which is 0, create random numbers. So that way you will have more flexibility. Okay? Or you can take, for example, combination of PG and dia-BP. Diastolic blood. Even here you have zeros. So maybe you can take the first 2 columns. ठीक है, तो इसका थरो एनालिसिस करने के बाद you decide which is the best. But अगर आपको जल्दी काम करना है, you don't want any zeros, then the easiest way is random values. Okay, so you do diab dot describe. So here BMI is 0. So what is the value for? So for BMI, the minimum value is 0 and 25% is 27.3 and maximum is 67. So now you have a range from 27 to 67. Or you want to take a 50% range, second quartile to third quartile. So kya range hai? 32 to 36. Or you can take 32 to 67. You have different combinations. But ensure that it doesn't go beyond the maximum value and it is also not zero. समझ में आ रही है? तेजस, कैसे करोगे?
जो वैल्यू के इंपॉर्टेंट है वो चेक करेंगे हम. इसमें 0 होगा तो 0 है सिग्निफिकेंट है कि नहीं वो चेक करेंगे. सिग्निफिकेंट जो आपको फीचर को अफेक्ट करेगा.
नहीं, अभी यहाँ पे मैंने क्वेरी लिखा है where BMI is 0. BMI 0 हो सकता है? नहीं हो सकता. तो उसके कितने रिकॉर्ड्स हैं? तो उसी का मैंने यहाँ पे क्वेरी लिखा है ना. Select from diabetes where BMI is less than equal 0. So it is selecting how many records. ये सारे. अब इन सब रिकॉर्ड्स के BMI मुझे चेंज करना है. So what should be the criteria for changing the existing values from 0 to something else? Minimum तो 0 है यहाँ पे, तो I cannot use 0. So if you want to do a quick fix, तो उसके लिए you do the describe function. तो describe में हमको क्या क्या आंसर मिला है? Measures मिला है statistics के. What is the minimum value which is 0? That is expected. What is the first quartile value? 27. What is median? 32. What is third quartile? 36. What is the maximum? 67. Right? अभी हमको कौन सा रेंज हमको लेना है to impute the value? Can I take from minimum to maximum? No, because it might give me one more zero.
25.
So I can probably take a value from 25. That sorry, 27. That is 25%. But another thing you have to remember is, can BMI be less than 27? यहाँ पे we are only fixing a problem, but you also have to think practically. Real life में can BMIs take a value less than 27 or not? Can my BMI be 5? हो सकता है कि नहीं? So उसके लिए थोड़ा research करना पड़ेगा. If I'm imputing these things, is this a valid value or not? What is the meaning of BMI equals 0? Does it mean a dead person, or does it mean it's a clerical error?
So, eliminating zero can be done by seeing that particular range of the data set for what is particular column.
Eliminating.
Yeah. This is what we are doing over here, right?
No, here we don't want to eliminate that.
Like fixing that.
Fixing.
Suppose if I have a range of 100 data, 100 records, out of those 10 records are 20 records are zeros. So while fixing it, if I see the remaining 80 records, if it comes between a range of like 100, something like 40, 30 to 60 in between. So with that also I can take something in between.
You have to take that because you don't have anything between 30 and less than 30.
No, like if I don't know anything, if I default take it as 0 into max. So 0 will be adding 1 0, so that is going to.
You might get it. That is what
you might get it.
One
you might get into an issue. And suppose 67 is way beyond my reach, like beyond the zone which I am seeing.
Correct.
So if I see somewhere in the data set, I will take some set and I'll see if like less than 67 or like quartile or 75 interquartile, quartile, whatever it is, we can take it from that set of that. It's not necessary to like keep 75% or 25%.
No, it is up to you to select the range.
Just verify with the data set and keep that value.
Yeah, the only check you need, the thing you have to ensure is you cannot have a 0. Okay, so 0 is out of the equation. Can I start from 1? Okay, so ask yourself, can my BMI be 1? Or is there a medical condition where, or a medical report that says the BMI of a person cannot be less than a number? कुछ तो criteria होगा ना BMI का. It is weight divided by height square or height by weight square, something like this. So if you do that calculation, what is the minimum number that comes? So start from that number. So yeah, imputation is a very tricky thing. बहुत सारा you need to keep in mind. It's not just take a number and impute it. That is a quick fixing thing. Okay, so for the time being, since BMI cannot be 0, assuming that, so how do you only for those records? So fix BMI equals 0 records with random values. So again, there are different ways to do it. So first, what I'll do, I'll take this data as it is. So there is a function called dot index. So dot index will return the record IDs of all the records where BMI is 0. So 9, 49, 60, 81, these are the record numbers. Okay, so I need to change only these records. Okay, you can verify it. You can use diab and within square brackets NDX. Sorry, not diab, diab dot. Okay, so diab dot BMI for these index values, everything is 0. Okay. Now, I want to generate random numbers. So you can say random BMI, okay, NP dot. Abhi BMI, is that an integer or is that a float? Float hai? So what is the function to generate float numbers? NP dot random dot cluster as type. मुझे generate करना है. Uniform. Okay. So what should be the minimum number? So can I generate from 25%? So here I'll put 27 because 27 represents first quartile, starting position. Okay, sorry, second quartile. Then what is the maximum value? 67.1. So here I will put, let's say 68. So between 27 and 68, generate how many numbers? I have to generate length of NDX numbers. Length of NDX क्या देगा? What is NDX? The list of index where BMI is 0. Okay. So length of index will give you what? Total number of records where BMI is 0. So this query is generate 11 random numbers between 27 and 68. So generate 11 random numbers between 27 and 68. समझ में आ गया? Now, is there a precision mentioned in the data? So have a look. Diab. So diab dot head. So BMI is 1 precision. That is 1 digit after decimal. So here you can put round off, comma 1. Okay. So I have generated the random numbers. अभी क्या करना है? इसको assign करना है. So now I can write diab of BMI for these index values equals okay. So impute the BMI with 0 with random numbers. So here randomly I have updated. Now you verify what are those values. So verify the update. So now you already know what are those index positions. So I'll simply write the diab.bmi of those same index numbers. And now you see, instead of 0, I have random numbers. Okay. So this is a quick fix method. But if you want to really understand the data well, and instead of guessing, you want to do a calculated guess, you have to further do the queries and then use a similar technique. Ankita, is this clear to you? Right. You may get different answers because it is random numbers. So you may not have the same values. 43.3 nahi hoga. Maybe it is something else. क्या तेजस हो गया?
जो नंबर है वो एफेक्ट नहीं करेगा. आपने रैंडम दिया है नंबर, ये एफेक्ट नहीं करेगा.
किसको एफेक्ट नहीं करेगा?
अपने मॉडल पे
एफेक्ट करेगा ना, क्यों नहीं करेगा?
रैंडम लिया है.
क्योंकि हमको एक्चुअल डेटा क्या है पता नहीं है. Unless we know the actual data, तब तक whatever impute you do will affect, either in a positive way or in a negative way. So do the same exercise for other zeros also. जैसे और किसमें था zero? PG उसमें ठीक है. हाँ. So you can do that later on. So do the same. Not do the same. Fix 0 for other columns. So you can do this exercise later on. So diabolic pressure cannot be 0, तो उसको भी impute करना. Okay, so now we will transform the data. What are the two types of transformation? Frequently used transformation, min-max and z-score. Okay, z-score को क्या बोलते हैं? Standard scalar. Okay, good. So try both the techniques. So I'm going to first use the standard scaler. So SS equals pre-processing dot standard scaler. And min-max के लिए है mm equals pre-processing dot min-max scaler. Okay, so use any one for now and try the other one after you have built the model. So I'm going to first convert this diab underscore SS equals SS dot fit transform. That is standard scale. Okay, so just check the data. So diab underscore standard scaler. Oh, sorry, not SS. So first convert this into the second. So values equals this. Okay, and then I also need to first diab underscore SS equals diab dot copy diab underscore and then it's diab dot copy. Always work with the two versions so that you have your original copy as it is. And then diab underscore SS dot iloc equals values. Okay, so now you can see that my data has converted itself into a standard scalar. अभी क्या करना है? The y variable has to be in its original form. Okay, so here the y variable is class equals diab of class. Now check the data. So now you see my features are in the transformed format. The y variable is in its original format. So similarly, transform the min max also. So values equals ss dot fit underscore transform is diab dot ilog all the rows, all the columns. Then diab underscore min max. Oh, sorry, not SS. This should be MM because it is min max scale. And then MM dot ilog values. And then diab underscore MM of class diab of class. Now see the difference between the standard scalar data and min-max data. This is the standard scalar data. And these are the classes. For the min-max, this is the data which is transformed. And these are the classes. समझ में आ रहा है? किसको? Y variable has to be in its original form. क्योंकि वो class, it is not a continuous value. नहीं तो आपका जो y value prediction है, it will give an error. It will think you are doing a regression problem. The formula is different. No? One is x minus mu by sigma, that is the first one. The other is x minus min x upon max x by min x. So you have you can try both and see which transformation gives you better accuracy. Because even that transformation makes a difference. Because one is between -3 to +3. Min max is between 0 and 1. So that might affect your predictions. Done. Chalo. Now next is we will split the data.
Compare मैं दोनों SS and MM को compare देख रहा था.
Same आ रहा है.
BMI column की जो values है, those are different. Values different है but comparison visually possible. So these all are positive. And
Here everything will be positive. Because everything is 0 and 1. Here it is between minus 3 plus 3. The class will be the same, record numbers are same. So same record in two different columns. वो एक बैडमिंटन का रैकेट आता ना, you should get that also. Okay, now we will split the data. That is, we split both the data, SS and MM. So we'll call this as train SS, train X for standard scalar, SX standard scalar, train Y for standard scalar. Now, can anyone tell me what is the problem when I do this kind of a transformation? I won't call it a problem, but
so depending on your output, there are few classes which gives you one. So there are few columns which gives total combined gives you classes 1, and there are few columns which combine the combinations gives you class 0. So we split it, so we don't know whether it will be towards 1 or whether it will be towards 0. So we don't know the combination of columns that will predict.
No, we can see the combinations of columns. See, the problem here is when I am splitting the data using the standard scalar, let's say 70-30 ratio. So I'll get some records in training, I'll get some records in testing. Okay. Now, if I split the min-max scalar, I will also get training and testing, but the records that I have in MM will not be the same as what I have in SS. समझ में आ रहा है? See, what we have done right now is the original data. Okay, so let's say it is 1, 2, 3, 4, 5, 6. Okay, now we have the min-max data. So let us say it is 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. Okay, and what is the row number? 1, 2, 3, 4, 5, 6. Now we have the standard scalar data. So let's say it is minus 0.1, minus 0.2, 0.03, 0.04, 0.05, 0.06. This is also 1, 2, 3, 4, 5, 6. Barabar? The class is 0, 0, 1, 1, 0, 1. Here it is 0, 0, 1, 0, 0, 0, 1, 1, 0, 1, 0, 0, 1, 1, 0, 1. Okay? Now we are splitting the data into training and testing. Now the data that we are considering is this one and this one. ठीक है? अभी मैं इसको split कर रहा हूँ. And I'm calling this as train data, train min max. So train min max पे let's assume I'm getting the records as 1, 3, 5, 6. Test पे क्या क्या आएगा? 2, 4. तेजस समझ में आ रहे? अभी मैं स्टैंडर्ड स्केल का डेटा लेता हूं. Now I'm splitting this. This is train standard scalar. Can I expect the same records to be there? नहीं. यहाँ पे क्या आ सकता है? It could be 2, 3, 4, 5 and 1 and 1, 2, 3, 6. I can get this combination also. I can. I'm not saying this is wrong. Maybe this is one way of randomizing your output. How your model behaves with two different data sets. This is a classic example. But if you want to perform SVM using the same set of hyperparameters on two different data, where the data is the same as in same training, same testing records, but transform different. Either be 1, 2, 3, other be 1, 2, 3, then this method may not be the right one. So you can fix. So what you should do, instead of transforming it now, you first split the data. Then using the split version, you do the transformation. So you already have the train X. So train X को transform करो. Understood? So when you transform train X into min max, you will get train X min max version. Train X को when you standardize it, you get train X SS. Then train Y test Y को कुछ करना नहीं है. It's already in the original form. So this is one way of working in case you want the same set of data. अगर अलग-अलग चाहिए, this is the way. So choice is yours. Clear? So for the time being, we will use different versions. You can do this exercise at home once you know how the implementation is. Try the same data and using the same data set, transform it so that the data in the min-max is the same as the data in the standard scalar. So split function. So here we will use the data diab underscore SS dot drop SS of mass Size equals 0. So you can print out the values, print next underscore SS dot shape. So 507. So 576 records in the training data. And similarly for the test data. (192) records in the testing data. कहाँ पे? Parameters.
We are drawing a class where the class is equal to 1.
So this brain test split function is going to split the data into two parts. But X will be split into train X, test X. And the Y will be split into so first parameter is X, second parameter is Y, third parameter is what is the ratio? The test ratio are given 0.25. So that means training will be 75%, testing will be 25%. Right? Now, how do you specify the list of features? What is my input? Input is my data frame. My data frame consists of X and Y. Right? My input for the split function is X and Y. So how do you specify the first parameter? Train test split, data frame. Now if I give the entire data frame, everything will be passed. Okay. So I will put commas. So here I am writing df dot draw. So which column should I drop so that I get only the groups?
Class.
I have to drop the Y variable. So what is the Y variable? You specify that here. So Y is in which index? 1. That means column. So specify the index. So what is the output of this command? This will result in df of nothing but this. What is the second parameter? Y. That means only Y. So how do I get only the Y from a data frame? Data frame. So I can select one column from a data frame. So I'm specifying that. So this will return. And the third parameter is the test size.
selection we have selection random dot selection लेते हैं तो selection क्या है तो जो टेस्ट और जॉब में चाहिए वो लेना चाहिए तो कैसा
Random state.
तो एक्टिव करेगा मॉडल पे
Random state is to replicate the data each time you want the same set of data. अगर आपको मान लो आपको किसी को डेमो दिखाना है and you are trying different combinations, एक combination अच्छा काम किया. Okay, so you want to perform or show the demo on that same combination. तो उसका आप random state देखोगे, मान लो 50 पे वो correct बहुत अच्छा काम किया. So when you next time when you say random state is 50, you will get the same training and testing data. That's it. वो थोड़ा it is kind of a biased way. Now do the same thing for min-max. So I'm just going to take this as it is and change this to train X min-max train Y test Y So this is going to be This is So here the count will be the same, 576, 576. And for the test, it is 192, 192. Okay, now if you are curious to know what are the records, you can do train X _ SS dot head. This is standard scalar data. And if I use train X _ dot head. Okay, now see the records. अलग है? So there could be some records which are common. Otherwise, you will get a random number, a random sequence of data. हो गया यहाँ तक सबका? तेजस, मनीष, Ankita, done? Okay. Now we'll go to the next step. Time क्या हुआ? 12:45. tomorrow will be the last day for SVM. We will do classification and we'll do the regression. So SVM hyperparameters. So we are going to first create the C values. So list of C values. So there is a function called log space. So log space is going to evenly create numbers between a given range. Okay. So for example, if I give -4 to 5 and 10 numbers. So it is going to create the numbers as 1.e minus 04. So what is 1e minus 04? 1 into 10 to the power minus 4. So which is 0.00004. This is 0.004. Oh, sorry. 1. This is 0.001. This is 0.001. This is 0.01. Then this is 1. Then this is 10. This is 100, 1,000 and 10,000. Clear your function. So you can decide how many values you want. Agar you want 10, what should be the limit? So here I'm taking the limit to be 10. So similarly, list of gamma values. So in NumPy, there are two functions that will generate random numbers, which are float in nature. One is random.uniform. One is random.random. Random.uniform will generate between any two numbers, whereas random.random will generate only between 0 and 1. Okay, so here also, if I give 10, so list underscore G, that is list of gamma, will generate random numbers between 0 and 1. Okay? Next. Set up parameters for grid search cross validation. Now, when we are doing आपने grid search किया है पहले? नहीं, okay. Now, when we are giving a grid search, we are giving the actual value of the hyperparameters, जो algorithm में use होता है. For example, max depth, min leaves. Okay, you must have seen those values when you were doing the decision tree or random forest. Okay, so that exact name has to be specified in the grid search. Okay. So we'll define the parameters like this. So parameters equals. So this has to be done in a dictionary format. So let's create the dictionary. So for SVM, we have kernel. This is the keyword. So what is the name of the kernel? Linear kernel. So linear kernel takes which parameter? C. So C, what are the values? List of C. Chair चाहिए, ले लो. Okay, it should be a list of parameters. So for the sigmoid kernel, the value for C is list of C, and for gamma, it is gamma. Next. नहीं बस अभी हो गया।
हो गया है। ठीक है 10 मिनट।
हो गया ये वाला। So we'll continue this tomorrow. This will by the time compile होते होते it's going to take a lot of time. हो गया, कल हो जाएगा ये, ठीक है। So हाँ ये इसके बाद unsupervised है. You have two algorithms in unsupervised, k-means and hierarchical clustering. So that will get over in Saturday, Sunday. So next Saturday we will finish unsupervised, and next Sunday we will finish time series. So by this month end, वो हो जाएगा as per the schedule. फिर tabules. Time series may get extended क्योंकि वो काफी बड़ा subject है वो. It may not get over in one class. क्योंकि वो theory itself takes some time to understand. जो concepts हैं, these require 2 hours for the theory portion alone. Lot of terms are there, so that may spill over. But as per the schedule, we are on track.
So जो हमारा ये पाइथन का जो एडवांस वर्जन बाकी रहा वो बेसिक पता है ना?
1 second. Ankita, any questions from you? Okay, so we will meet tomorrow then. If we have anything, then tomorrow we can discuss. Okay. So have a good weekend. I'll see you tomorrow then. Bye.